Okay, to begin with, just graph sine and cosecant. The one rides on top of the other. And don't worry about that problem on the bottom of the screen. We'll just graph sine, plain old cosecant. Label the four major spots, which are here, 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 and here. Okay, here's what I hope you were doing. Sine goes like that. The numbering, 2 pi, pi, pi over 2, 3 pi over 2. Hope you can kind of do that in your sleep by now. That and that. Is there anything that could be considered left off of this? What did I not do that I probably should? Asymptotes. So if I was really going to end up doing this graph when it's all said and done, I don't really need the sine graph, do I? So now, if you would, please just erase your sine graph. Get it out of there. And the numbering's all going to change too, because when we do a problem like this one, we have to change our numbers on the x-axis. It's no longer 2 pi out there. You figure it out based on the little formula, period equals 2 pi over b. Why is it 2 pi? Because that's the normal length of the period of sine or cosecant. All right, 2 pi over b, what's b? 3/4. I want you to try to finish this problem now. So all you have to do is renumber your graph, and you'll have it. Renumber it based on this constraint and this constraint. Those changes. All right, the 2 in the front makes it that's really easy to do. That just means that this can't be a 1 and a -1. It has to be a 2 and a -2. Get that? All right. Then this one right here, that's our b. So we go 2 pi over b, 2 pi over 3/4. And the period then, I take 2 pi divided by 3/4 is the same as 2 pi times 4/3, which would be 8 pi over 3. That's a weird period, but it's what it is. So then hopefully you put that right here. And if that's 8 pi over 3, this would be half of that, which would be 4 pi over 3. And then half of that is 2 pi over 3. And then I can say 2 pi over 3, 4 pi over 3. This must be right here, 6 pi over 3, which is also known as 2 pi. No, I wouldn't have marked that wrong if you just said 6 pi over 3. As long as you got it labeled. All right, any questions about that one? Who got that one right? Yeah, excellent. Okay, moving on. And if I start with cosecant and secant, it's the same exact kind of a problem. So just lightly graph in cosine, like dotted lines or something. Then make your secant graph, and then try to do this. Start by doing the parent, and then just see about moving it then, or renumbering, or whatever you need to do. Okay, here's what I wanted you to do. Secant looks like this. Rides on the back, also here, also here. Now if you wanted to, if I am supposed to graph one period, did I, when I graphed the blue thing, did I graph one period? Yeah, I did, because I did one down and then 2 half ups. You know what I mean? Otherwise, I could have gone over here and said, I'm going to make a full one over here. See how I still graphed a full period of it? It's okay to do that, as long as you have a set, a complete set, you know? If they wanted 2 periods, I'd need 2 complete sets, but anyway. All right, so I'm going to stick with that way right there. And then I'm supposed to do this stuff with the negative. The negative on the outside means an up-down flip, so I'm going to rewrite that as a red graph here. It's going to be like this, and then up here. You see how the blue ones got reflected up and over to be the red ones? Okay, now I'm going to get rid of all this other distracting stuff. I'm left with my red ones right there. And then the last thing is, what's that plus pi over 2 thing? I shifted. Notice I never actually changed these numbers here because there's no b term that changes anything. So those are the original numbers, which, by the way, are 2 pi, pi over 2, and 3 pi over 2. Why didn't they change? Because there's no b number. B is 1. Okay, so then how far is this pi over 2 shift? I got to look at my numbering and say from here to here is a shift of pi over 2. That's my little yardstick I use to say if I move it that far, I'll be moving it right. So I'm going to take this up and say, okay, move this over that far. Boop. Take them down here. Say I'm going to take the peak of this and move it over that far. Boop. There we go. Done. If I was going to put in the asymptotes, where would they be? They would be here. I'll use red here, and here, and here. Now, could I get this marked wrong? Yep. Because I haven't labeled in the area where I have a graph. So if you don't label these, I'll be okay with that because that'll mean it's 1 and -1. But if you don't label these, I'd have to mark it wrong. Because it's a plus, remember how it's, there you go. Okay. And then, what else am I feel like? Oh yeah, I was going to do this. Any questions on that one?
Can you go over the negative part? How did you do it again?
Sure. I'm going to go back in time to before I was crafting. Back. There we go. There's the original.
Yep, that's fair.
And then the negative here makes it flip up, down, right? So I take this right here and I put it down here instead.
Okay.
And I take this right here and I put it up there.
What if you had a negative on the inside? What would you do for the parent?
You would go left, right, flip, but we don't do that to you because they get really complicated because they go forever. You know what I mean? And then if you try to flip it over, it gets complicated. Yes?
What's the phase shift when on a test could it be really like
Weird phase shift?
hard
I suppose it could be. It's not likely they're going to mess with that. So it's likely to be pi or pi over 2 or maybe pi over 3 or something like that. Something that you'd be able to find. All right, let's move on. Next one. If tangent is made up of sine over cosine, what would happen if cosine was ever 0? You'd have an error or undefined, or what on the picture would you see there? An asymptote. You'd have asymptotes wherever cosine is 0. So if I were to graph cosine for you and say, here's what cosine looks like, then wherever it touches, like here and here, there should be asymptotes there, right? And there are. So for tangent, there's asymptotes here, and then here, and then here. And then tangent lives right there. So there's my tangent base graph. Start with that, and then would you please try to answer this question? 2 periods of 5 tangent of 2x. Yes, that would be okay. Yep, that works. Yes, the period for tangent is pi. It gets over with quicker. Instead of 2 pi, it's just pi.
So this is a like vertical stretch by 5. And how, do you have to put like little dots in there, like Can you just?
You don't have to. You can just renumber that first point as instead of being 1, it can be a 5. And you've covered it.
So that's.
Yep. Okay, here's what I'd be looking for here. The original one's period is pi. Watch me make a mistake. Oh, this one's period is pi, so I'm going to put a pi right there. Because this whole distance here, that's pi, so what should it be? Pi over 2. That's the parent one, and then I'm going to go and mess with it but that's where the parent looks. Now I'm going to mess with it with this and say, okay, now this 2, how does that factor in? Period equals not 2 pi over b, pi over b, because the formula's changed because we're talking about tangent, and tangent's period is pi. All right, so it's pi over b, and now I'm going to stick in b is 2, so I'm going to stick in a 2 right here. What?
That 2 is on the inside.
Yeah, but you still put it into the formula as a 2. If it's b, that is b, right? b is 2, so I put a 2 right there. So now the period is now pi over 2. And again, some kid might look at theirs and think, oh, I've got it right then, because see, my period is pi over 2. No, this distance right here to here has to be pi over 2. So then these numbers have to change to be what and what? Pi over 4 and negative pi over 4. You get that? The total here has to be pi over 2. So then it's pi over 4 and pi over 4 total. 1/4 of a pi and 1/4 of a pi makes a half of a pi. All right. And then, all said and done, I'm going to go back and look and see, did I do everything? Did I do this 5 yet? No, I didn't. How do you do that 5? Well, this thing needs to be stretched up, so I'm going to renumber this from being a 1 and a negative 1 to being a 5 and a negative 5. All right. And then the last thing is, I'm going to look back at the problem and say, did I do the 5? Yeah. Did I do the 2? Yeah, I factored that in because I changed the period on the thing. And then, 2 periods of. Kids are going to forget that on the test. And I'll have this beautiful graph labeled perfectly, and they'll only have 1 period. It's really so easy to just do the next period and over. It's like, okay, now that I did that, I just copy it over here. And I just have to number a couple more spots. If that's 1/4 of a pi, that's going to be 2/4 of a pi, or pi over, I'm going to call it 2/4. And then it's 1/4, 2/4, and this is 3/4. Now I have graphed 2 periods of 5 tangent of 2x. Lots of red, white, and blue. And black, too. Black and blue. That'll be a cool flag. All right, cotangent. X over y equals cosine over x. So, or cosine over sine. So, when does cotangent ever have problems? When sine is 0. If sine's 0, it'll have asymptotes. So, the biggest mistake I see on cotangent is kids think, oh, tangent looks like this, cotangent looks like this. Wrong. Cotangent kind of looks like that, but it's moved over here. Now, it's an important point to make is that if you went over 1 increment and up 1 increment, you would have a dot right there. And if you went over 1 increment and down 1 increment, you'd have a dot right there. The point is there's some kind of symmetry there. All right, it's not that big of a deal, but I just don't want you to think it's anything goes in there. You want to try to make it symmetrical. All right.
Do you want us to label the dots?
Nope. This is 1 and negative 1. It'd be great if you'd label them. If you don't, I'm going to assume they're 1 and negative 1. And now if you actually had to do this problem right here, 2 periods of that. Why don't you try to figure out what it would look like? Give it a shot. Keep yourself with me. You only have about 7 more minutes. And they're all pertinent test type things you need to know. Okay, so the normal numbering on this thing would be pi because it has a period of pi. But that changes because of this. So I go period pi over b, and b is 2, so it's pi over 2. So the total distance from here to here should be pi over 2. So there we go, pi over 2. Then, what's that minus 1 do? Takes the whole graph and does what? Moves it down 1. How far is 1? Well, we've already labeled it on the graph, so we're kind of stuck with going that far then. So you take this and you move it down 1. And I have to go with it. There we go. Raise your hand if you had that one right. All right. Do you think I have it right? You think I have it wrong?
Yeah.
Oh, tell me what you think I did wrong.
You don't have a second period, and you don't.
Oh, okay. 2 periods. And there's something else?
Well, I mean, by a byproduct of not having the second period, you don't have the graph fully labeled.
Okay. All right. So yeah, you're right. So the other period, if I'm gonna go make the normal one, it'd be like this. But then I gotta shift it down. Shh. There we go. And then I probably need another asymptote too, if you're really gonna be picky. And then this would be pi over 4, pi over 2, fourth, 1/2, 1/4, 2/4, 3/4 of a pi, and then pi. Marzano.
Yeah, the Italian guy. He's 50.
Go after the Italian guy when all else fails. All right. So there you go. I think that's it, isn't it? And it's okay to be picky. Someday you'll be that controller of the big company, and you'll be like, you know, they're not going to allow us to do this tax-wise. And your boss will say, oh, just do it anyways. And then you'll all get in big trouble, get thrown in jail. So sometimes you have to be picky. Got to follow the rules. So, bottom line is, it is okay to be picky. Sometimes when it really matters. If you do it wrong, it's like a little brain surgery and I'm off by a centimeter. It's not that big of a deal. Yeah, now you just took away their memories of their favorite childhood experience because you burned the wrong spot in their brain. And the tumor's still there, yeah. All right, so there's times when being picky is important. All right, moving on. Bit of review. All students take calc. All students take calc. That's meant to remind you, where is sign negative? Okay, those two. Where would cosine be positive? A and C. How about where would sine be negative but tangent be positive? Sine would be negative, tangent positive.
Oh, no, just T.
Just T. You're right. Okay, good. Next thing, reference triangles. Let's say I had a 120-degree angle. You can't have a 120-degree angle in a triangle, at least not in a right triangle. So if that's 120, then I draw this little thing with a reference angle right there. And if this one's 120, what's this one? 60. And then if that's 60, this is 30. And then it's a 1, 2, what? Square root of 3. And then which one of these is negative? Very easy to forget that. Next thing is, which of those angles is called the reference angle? The 60. And which two types of triangles do you have to know all about? 30, 60, 90 and 45, 45, 90. And since we didn't do the 45, 45, what are the numbers for 45, 45, 90? 1, 1 square root of 2. Very good. Okay. And then if there is such a thing as SOHCAHTOA, and it tells us the sine, cosine, tangent, what would CHO, SHA, COW tell you? Can you get away with not knowing that? Sure. But if you saw secant of theta is equal to 4/5, you ought to be able to tell me, is the 4 the hypotenuse or the adjacent or the opposite side? Well, if you look at this, you'll know it's SHA, hypotenuse over adjacent. If you don't want to do it that way, you can say, well, just as good as that is cosine of theta would be 5/4. And cosine is ca, adjacent over hypotenuse, but you're still telling me that 5 is the adjacent and 4 is the hypotenuse. And doing it this way is faster. Either way is fine. Whatever works for you. Oh, you're right. Those numbers were just completely made up, and you're right. That's impossible to have the hypotenuse be shorter than the adjacent side. Good point. Okay, I'm just making up numbers. This one, it's a transformation. Just picture it in your mind. Don't draw. Do you know where tangent would be? And then picture for yourself, is it going to get squished or stretched? Okay. So final answer. Tangent would go like this. When I stretch it this way, instead of actually stretching it, what am I going to do? Change the numbers. The numbers would normally be, well, the period's pi, so I'm going to put a pi here. No. Period's pi, so I'm going to say the whole thing has got to be pi, so this would be pi over 2. And then this would change it. It'd be period equals pi over 1/2, which would be divided by half and times by 2, so it's going to be 2 pi. And so now, if the whole thing's 2 pi, then this has got to be pi and negative pi. You get that? Okay. Hardest, it's not the hardest. Last question. You got to know what order to do it in. Do you get that there's a phase shift going on in there? What's the phase shift? Nope, not 2/3. Pi. It's right pi. And that 2/3 is not a phase shift, it's the amplitude. The 4 is what letter? The B. And what does the 4 do? Make it narrower or wider? Narrower. Would I actually make my graph narrower? No, I would renumber it. And the last thing is that 7. Would that actually shift it somewhere? Yep. Down where? Down 7. All right. Then what order should I do it in? I've told you to start with the inside. So of these two, which one do you think would normally go first? The 4, and therefore we use the pi. So we do our phase shift first, right pi. Next, number 2. 1/4 as wide. Then we go to the outside and 2/3. We do it in the normal order, and this would normally come first because it's a multiply, and that would normally come second. So this is next. 2/3 as tall. In other words, it's shrunk vertically. And the last thing is down 7. Is there another way it could be done? Yes. You could start on the outside, do all of those things, and then go to the inside and do them in the opposite order. But I like this way best. Start on the inside. Yes?
So when we start at the inside, we start with what we normally would do last.
Yes. So if you're looking at the inside there, normally there's a multiply by 4 and a subtract pi. Multiply is normally first, so you don't do that first. So you do this first. And this will be second. This will be third, and this will be last. All right. And that's all we need to know for today. And the worksheet is on its way.